This 2012 Volkswagen Crafter began its life as a standard commercial van, over a decade old, built for cargo, not comfort. But in this project, it becomes something else entirely. A self-contained workspace and living environment designed to operate off-grid through the summer months. The build does not start with aesthetics or expensive gadgets. It starts with a practical question. How do you live and work independently for long periods without infrastructure while maintaining durability, safety, and serviceability? Every modification here is driven by engineering logic, from treating the steel body to control condensation, to selecting insulation materials suitable for sustained summer heat, to planning a layout that respects load distribution, center of gravity, and daily function. This is not a van built for social media. It is a mobile structure executed by someone who understands the limits of materials, structural systems, and the vehicle itself.
The first stage of the project is not visually impressive, but it is structurally critical. He removes all factory linings, the old floor, and the cabin bulkhead, stripping the van back to its bare shell. On a commercial vehicle of this age, this step is non-negotiable. Old panels often conceal accumulated dirt, trapped moisture, and early-stage corrosion. Ignoring this would compromise every layer added later. Once stripped, the entire cargo area is pressure washed and mechanically cleaned. The goal is not appearance, but exposure, revealing the true condition of the steel body. Surface rust is treated while still shallow, abrasion, neutralization, and protective repainting. Special attention is given to paint chips caused by stone impact along the underbody and lower panels. These small defects are often overlooked, yet they are the fastest entry points for corrosion due to water and road salt.
The roof rack is custom-built using galvanized uni-strut. This is a deliberate engineering choice. Uni-strut allows solar panel loads to be distributed across existing roof ribs while remaining adjustable and serviceable in the future. Just as importantly, it minimizes unnecessary permanent penetrations in thin roof sheet metal. Next comes the irrevocable step, cutting a large opening for the roof ventilation fan. Roof cuts always carry risk if deformation and vibration are not properly controlled. Measurements are precise, and the cut is aligned with structural ribs to avoid weakening the shell. The cutout is reinforced with a wooden frame, creating a flat, rigid mounting surface for the fan assembly. Waterproofing is treated as a system. Sealant, gaskets, and protective coatings applied in multiple layers, including exposed steel edges. After the roof, the side body panels are the next area to be modified, with no less risk involved. He cuts into the van's body to install windows, a step that directly affects overall structural rigidity. Unlike fixed buildings, a van body is made of thin sheet metal that constantly flexes and twists in motion. Cutting in the wrong place can interrupt load paths between stiffening ribs, leading to vibration, noise, and long-term cracking. Window positions are carefully selected between vertical ribs, avoiding primary structural members. All exposed steel edges are immediately treated, deburred, primed, and protected against corrosion before installation. The window frame does more than hold glass. It functions as a reinforcement ring, restoring stiffness to the opened panel. Waterproofing is applied as a layered system, allowing controlled movement without breaking the seal. All unused factory holes are fully sealed, eliminating pathways for splash water and rising moisture. The floor framework is built from moisture-treated timber. Notably, the entire structure is bonded using structural adhesive and high-strength tape, without drilling new holes into the steel body. This preserves the factory anti-corrosion layer and avoids creating new moisture bridges. The new plywood floor is cut using the original floor as a template. This ensures a precise fit to the van's irregular shape, minimizing gaps where heat loss and condensation typically occur. For insulation, both the floor and wheel arches are lined with natural sheep's wool. This material regulates moisture, resists mold, and performs well in enclosed, vibration-prone environments. Finally, the floor is installed and the wheel arches boxed in. A dry, insulated, and structurally stable base, forming the foundation for everything built above it. He begins the sofa bed build with its structural frame. The material of choice is plywood, between 12 and 18 millimeters thick, offering sufficient rigidity without unnecessary weight. In vehicle conversions, weight affects more than fuel consumption. It directly impacts suspension performance and driving stability. Every millimeter of material is therefore a balance between stiffness and mass. Rather than relying on numerical measurements, he uses a story stick, a physical measuring stick taken directly from the van's interior. This technique is common in boat building and custom cabinetry, where perfect square geometry does not exist. A van body is never truly straight. Curves, twists, and tolerances vary along its length. Relying solely on tape measurements introduces cumulative errors. The story stick transfers real dimensions directly from the vehicle to the plywood, eliminating that risk. The sofa is designed around 3 distinct compartments. 2 are dedicated to electrical equipment, batteries, inverter, and protection systems, fixed in place with controlled ventilation. The third is a large drawer, serving both storage and structural support. The pull-out bed mechanism is the core of the design. Instead of relying on expensive, heavy-duty slides, he adopts a more efficient solution. The bed surface is built from slats, with every second slat designed to extend outward, creating the required length when deployed. At full extension, the large drawer beneath drops down to contact the floor. At that moment, it stops acting as storage and becomes a load-bearing leg. Weight is transferred directly to the vehicle floor, relieving stress on both slides and plywood structure. The result is a system capable of supporting 2 adults, smoothly converting from sofa to bed, and reaching the dimensions of a full double bed without restricting legroom, exactly as intended from the start. The off-grid electrical system begins on the roof, where all energy is generated. He installs 2 200-watt monocrystalline panels. Wired in series, they deliver a total of 400 watts at a voltage matched to the solar charge controller. Series wiring does more than simplify connections. It reduces cable losses, and it improves performance under uneven sunlight, a common condition when the vehicle is partially shaded or parked at an angle. The panel frame and mounting system are custom-built to attach directly to the factory roof rails. This approach avoids penetrating the main roof skin, and it distributes dynamic loads through mounting points designed by the manufacturer. However, routing solar cables into the vehicle still requires one additional roof penetration. The entry point is carefully selected. Exposed steel is treated. A dedicated waterproof junction box is installed. All penetrations are sealed in multiple layers, designed to remain watertight under heavy rain and constant vibration. In a mobile electrical system, solar panels are only as good as their installation. They must remain secure against wind, movement, and weather, and reliable enough to perform year after year on the road.
At this stage, the off-grid electrical system reveals its full structure. It is designed around three independent power inputs. The first is roof-mounted solar, the primary energy source when the van is stationary. The second comes from the vehicle's alternator through a DC to DC charger. This allows safe, controlled charging while driving without overloading the vehicle's electrical system. The third input is external shore power, used when parked at campsites or connected at home. At the center of the system sits a 12-volt, 100-amp-hour lithium battery. It is not oversized, but when paired with proper energy management, it is fully sufficient for daily use. Power flow is regulated through the solar charge controller and the DC to DC charger. From there, electricity is distributed via bus bars and dedicated DC and AC fuse boxes. An inverter converts direct current into 240-volt AC power, allowing standard household appliances to operate normally. A shunt monitors the system in real time, tracking current flow, power consumption, and battery state with precision. Battery and solar disconnect switches are clearly positioned, prioritizing safety and fast fault isolation. All components are integrated inside the sofa structure, discrete, accessible, and designed with long-term serviceability in mind.
The ground connection is bonded directly to the vehicle chassis. Paint is removed to ensure clean metal-to-metal contact. Cable routing follows a strict electrical sequence. High current cables are installed first, running from the battery to the inverter and the main bus bars. Establishing these paths early reduces cable crossings and minimizes long-term heat risk. All cable lugs are crimped manually using a hydraulic crimper. The process is slow but essential for reliable electrical contact. In a system exposed to constant vibration, a poor crimp will eventually become a hotspot. Every circuit is fused without exception. In off-grid systems, fuses are not optional. They protect not just individual devices, but the entire build. If you find this interesting and helpful, don't forget to like and subscribe to our channel to support us. Once powered up, the system starts cleanly and remains stable. Bluetooth-enabled components allow real-time monitoring and control directly from a smartphone. Real-world testing confirms the design. Charging from the alternator while driving. Solar output reaching approximately 150 watts in direct sunlight. Phones charging fully off-grid. and even a 3D printer running directly from solar power. At this point, the system is no longer theoretical. It is operational, ready to support both work and life on the road. Sound-deadening material is applied directly to large metal surfaces, the panels most prone to resonance while driving. Only areas experiencing significant vibration are treated. The insulation layers added later will further absorb vibration and airborne noise. Because of this, full coverage is unnecessary. He moves on to building the wall framework. The material selected is 12mm plywood. The framework is fastened directly to the vehicle body using self-drilling screws rather than riv nuts. From a purely technical perspective, riv nuts provide cleaner connections and easier removal in the future. Self-drilling screws allow rapid installation straight into the steel ribs, eliminating additional steps and specialized tools. As long as each penetration is properly treated for corrosion, this method is more than adequate for lightweight interior structures. The 12mm thickness is a deliberate compromise, thin enough to follow the natural curvature of the van walls, yet thick enough to hold screws securely, supporting future panels, cabinets, and interior fixtures.
When transitioning into the kitchen and main storage system, he begins with the non-negotiable elements. Two 25-liter water containers, one for fresh water, one for waste, must be removable directly through the sliding door. They are accessed without passing through the living area. This layout improves daily usability and significantly reduces the risk of spills and odors inside the van, a common failure in poorly planned builds. The next fixed component is a top-opening refrigerator. It is positioned above the wheel arch, a space often difficult to use, and integrated into a pull-out drawer for easy access. This solution turns dead space into functional storage, while maintaining better cooling efficiency than front-opening fridges in moving vehicles. Construction begins with the fridge drawer itself. The reason is simple. Tolerances are extremely tight. Once the drawer operates smoothly, at the correct height and full extension, it becomes the geometric reference for building all remaining cabinetry.
With the main cabinetry now in place, he installs the remaining kitchen components, smaller in size but equally critical. The gas stove compartment is designed for a portable unit, kept separate from the fixed cabinetry. This increases flexibility, allowing cooking both inside and outside the van. At the same time, it reduces the risk of gas accumulation within an enclosed space. A dedicated cutlery drawer is positioned at an ergonomic height. It is deep enough to secure utensils while driving, without consuming valuable living space. The most revealing detail appears in the cabinet doors. Rather than using protruding handles, simple hand-cut openings are employed. Inside a van, every projection can become a collision point, especially at knee level. By eliminating handles, the design reduces injury risk while keeping surfaces clean, flush, and unobstructed, essential for movement within tight interior spaces.
The benchtop is where the project intentionally slows down. Not because the work is difficult, but because it cannot be rushed. The material comes from reclaimed timber, salvaged from a church more than 150 years old. Old wood carries history, but it also carries risk. Each board is ripped, planed, and glued with care. Grain orientation is deliberately controlled to reduce internal stress and limit warping in the van's constantly changing climate. The sink opening is cut with precision. The rear edge is reinforced and extended into a backsplash, protecting the wall from water and impact. Old nail holes are filled with black epoxy. They are not hidden, they are preserved as part of the material's story. The surface is finished with wipe-on polyurethane, chosen for durability, moisture resistance, and long-term wear, rather than chasing so-called food-safe claims that offer little value in a mobile environment. The same process is repeated for the workdesk surface. Two benchtops built the same way. Reclaimed material, treated correctly, prepared for a new life on the road.
The frame is built using half-lap and cross-lap joints. These joints are simple to fabricate, yet highly reliable. They rely on direct wood-to-wood contact rather than metal hardware. This provides multi-directional strength and strong resistance to loosening under constant vibration. Just as important, these joints tolerate irregular geometry. They allow the structure to remain accurate even when surrounding surfaces are not perfectly square. Once the frame is fully assembled, all surfaces are sanded. A polyurethane finish is then applied. The coating protects against moisture and surface wear while preparing the structure for future drawer installation and additional hardware.
The van, however, is not parked on perfectly level ground. Rather than relying on a traditional spirit level, a tensioned string line is used as the horizontal reference. This method aligns the cabinets visually across the entire interior, regardless of slight ground slope or natural body twist in the vehicle structure. Cabinet dimensions are kept intentionally modest. Storage volume is not maximized at all costs. Oversized overhead cabinets can quickly create a cramped, oppressive atmosphere, especially in areas where people stand or sit for extended periods. By limiting cabinet depth, the space remains open, balanced, and comfortable for everyday living. Three overhead cabinets are constructed, one above the kitchen, one above the work desk, and a longer unit running the full length above the sofa bed. The cabinet is reinforced using riv nuts combined with angled mounting brackets. This approach transfers load directly into the cabinet's primary frame instead of relying solely on finished wall panels. Forces are distributed, stress is reduced, and long-term stability is improved. In vehicle conversions, good design does not mean never changing direction. It means adapting when real-world conditions make themselves known. He turns his attention to the ceiling, the most geometrically challenging surface inside the van. An additional ceiling frame is installed. It is fixed directly into the steel roof ribs using riv nuts, providing structural strength while remaining fully serviceable. The ceiling design intentionally avoids flat planes. Instead, it adopts a triangular framework, inspired by 3D mesh systems used in lightweight engineering and architectural structures. Triangles offer inherent stability. They adapt more easily to the complex curvature of the van roof, reducing stress concentrations and minimizing long-term warping or panel sag. This ceiling structure also integrates aluminum profiles. These serve both as secondary framing and as mounting channels for LED lighting strips. Aluminum dissipates heat efficiently, extending LED lifespan and ensuring reliable performance over time. The result is clean, continuous lighting, integrated directly into the structure without visual clutter.
The wall panels are finished using 7mm plywood. Thin and lightweight, the material flexes just enough to follow the van's natural contours without adding unnecessary mass. Panels are mounted with exposed screws, leaving all fixings fully visible. This is a deliberate choice. Visible fasteners allow rapid removal for future access to wiring, insulation, and structural elements behind the walls. In exchange, a distinctly technical aesthetic is accepted: honest, functional, and purposeful. From the beginning, mounting locations for critical components are integrated into the wall system. AC power outlets, USB charging ports, and the battery monitoring display. This approach eliminates ad hoc cutouts later in the build and keeps the layout clean and intentional. All wall surfaces are treated consistently, including the sliding door and the rear doors. When closed, these elements visually merge with the fixed wall panels, removing the common disconnect between doors and surrounding structure. At this stage, every decision prioritizes long-term usability, not for display, but for living with the vehicle.
Before final assembly, he fully disassembles the cabinetry, wall panels, and ceiling sections, not to rebuild them, but to paint each component individually. The process takes more time, but it provides better access, cleaner edges, and a higher surface quality than painting in place inside a confined interior. The color palette is selected with care. The kitchen cabinetry is finished in lichen green, a quiet reference to the moss that once covered the van's roof when it was first acquired. A small detail connecting the vehicle's past to its new identity. Overhead cabinets, walls, and ceiling are painted in a warm seashell white. This tone reflects light efficiently, making the interior feel brighter and more spacious, essential inside a closed cargo van. The pull-out bed is finished in a darker gravel gray. This creates visual contrast and clearly defines the primary living zone. Frames and trim elements are painted in a very light gray. They do not demand attention, but they add depth, definition, and structure to the interior.
Once the paint has fully cured, the off-grid electrical system is reinstalled for the final time. All components previously removed for interior finishing return to their original positions, now cleaner, more refined, and fully integrated. Cable routing is organized again, following a clear hierarchy. High current cables are installed first. Signal and control wiring follows after. The battery, fuse blocks, and main bus bars are secured with correct spacing, allowing for heat dissipation, visual inspection, and future service access.
Each electrical load serves a clearly defined purpose and usage pattern. A dedicated circuit is assigned to the roof ventilation fan. It operates independently, reliable, and available even when other systems are powered down. USB outlets are positioned at the kitchen and beside the bed. Placed exactly where they are needed, they reduce loose tables and eliminate unnecessary adapters. Lighting is divided into 3 separate LED circuits. The work desk uses cool white light, providing sufficient illumination for extended tasks and detailed work. Warm under-cabinet lighting creates ambient illumination and reduces eye strain during evening hours. The triangular ceiling is the most labor-intensive element. It is built from 12 individual LED strips, requiring extensive hand soldering to maintain clean wiring, consistent brightness, and precise alignment. All lighting systems are controlled through touch-sensitive dimmer switches. Fewer mechanical components, fewer potential failure points, and a cleaner interface for a compact living environment.
RGB LEDs are intentionally avoided, not for aesthetic reasons, but to eliminate flicker and inconsistent light quality, issues that become impossible to ignore when living long-term in a confined space. The sink is mounted using silicone sealant combined with mechanical clamps. The silicone provides waterproofing and vibration isolation. The recycled timber benchtop is installed in its final position. There is a minor discrepancy, 3 millimeters short. Instead of rebuilding, the edge is patched. A practical decision, consistent with a real-world DIY approach. The cold water system uses a straightforward layout. Fresh water flows from the container to the pump, through a check valve, then split to the tap and the spray hose. Fewer components mean fewer failure points. Wastewater is routed to a gray water container with a vent line exiting the vehicle to meet New Zealand self-contained certification requirements. Both water containers are restrained using physical stops and tie-down straps, preventing movement during braking or sudden maneuvers. Flexibility is built directly into the kitchen layout. A folding table at the sliding door uses a turnbuckle to level the surface on uneven ground. An internal benchtop extension adds usable workspace, and a two-piece timber cutting board fits precisely over the sink, transforming a compact kitchen into a functional work surface.
The kitchen benchtop is expanded using a folding mechanism. When needed, the surface unfolds to provide additional workspace. When stowed, it folds flat against the cabinet, preserving clear floor space inside the van. The refrigerator is upgraded to a dual-zone unit. Independent temperature control allows refrigeration and freezing to operate simultaneously, a critical advantage for extended travel without frequent resupply. The dedicated gas stove compartment is removed and replaced with a standard drawer. The reasoning is straightforward. A portable gas stove is not always used inside the van. Keeping a fixed gas compartment inside the vehicle means giving up space for a function that sees limited use. Once the paintwork is complete, all panels are installed for the final time. At this stage, there is no room for experimentation. All dimensions, alignments, and fixing points are already locked in. Before everything is sealed, sheep wool insulation is packed throughout the vehicle body. This natural material regulates moisture effectively, reducing condensation, a persistent issue in vans used across cold and humid climates. Sheep wool also provides acoustic benefits. It absorbs resonance inside the metal shell, making the interior noticeably quieter both while driving and at rest. Cabinet backs are closed using 3mm plywood, stiff enough to maintain structural integrity, yet light enough to avoid unnecessary mass.
The windows were also fitted with curtains and screens to ensure light while maintaining privacy. The desk is completed with the same technical mindset that's applied throughout the build. The drawer design is intentionally simple, avoiding unnecessary mechanisms that add weight, noise, or long-term failure points. Aluminum slide rails are chosen instead of heavy, expensive ball-bearing slides. Aluminum is lightweight, it has fewer moving parts, and it holds up better in the constant vibration environment of a moving vehicle. To finish it off, a mechanical latch is added, not for convenience, but to make sure the drawer stays locked in place while driving.
The toilet solution here is temporary. Very temporary. It repurposes the desk chair. Not comfortable, not attractive, and definitely not something made for social media.
In the cabin area, he focuses on a very practical detail. The shelf edges are rounded over, not for aesthetics, but to avoid hitting his head. The underside of the shelf is lined with carpet. This layer softens impacts and helps dampen noise when accidental contact happens, especially in low light.
The heavy, full-size hinge door is replaced with a frosted acrylic sliding door. The reason is weight. Large hinge doors place significant load on hinges and cabinet frames, especially in a vehicle subject to constant vibration. Frosted acrylic is much lighter, reducing inertial forces during braking or on rough roads, and lowering the risk of hinge loosening or frame deformation. The floor becomes a clear lesson in trial and error. Initially, industrial rubber flooring is tested. On paper, the material is durable and waterproof. In practice, it is too dark and abrasive on the skin when kneeling or working on the floor. This is a straightforward failure, not due to workmanship, but due to choosing the wrong material for a living space. The solution is to switch to commercial-grade vinyl, brighter, easier to clean, and far more comfortable for daily use. Vinyl may not sound technically impressive, but it is the right choice. Curtains are installed to fully cover the windows at night. Magnets are sewn into the edges. They hide awkward gaps and hold the curtains in place without complex rails or hooks. Several small but important additions follow. Grab handles improve safe entry and exit. Floor trims protect material edges and reduce trip hazards. Smoke and carbon monoxide detectors are fitted, unobtrusive but essential in a sealed space with electrical and combustion systems. The final tasks are completed as the project approaches its conclusion. The infotainment and driving aids are installed, a DVD head unit, central display, and reversing camera, not for luxury, but to make daily use more practical. The softest part of the interior comes last, the bed and sofa cushions. Foam is cut to match the actual frame dimensions, not standard sizes. Cushion covers are sewn by hand using repurposed bed sheets. Not visually perfect, but easy to replace, easy to wash, and very much in the DIY spirit. The cushions are divided into multiple sections. This allows flexible conversion between seating and sleeping modes, keeps windows unobstructed, and maintains an open feel when the bed is not in use. At this point, all systems are complete. The van is no longer a work in progress, but a living space, ready to be used and refined over time. From an old Volkswagen Crafter, this project did not begin with polished visuals, but with bare metal, surface rust, and a long series of technical decisions. Every stage revolved around a single question: will this actually work in real life? Not every material choice succeeded. Not every solution survived to the final build, but every adjustment added experience. The off-grid electrical system was built for reliability. The interior was designed to be serviceable, repairable, and lived in long-term. A small space, yet enough for work, daily life, and travel without dependence on external infrastructure. This is not a van built to be displayed. It is a van built to be used. If you have technical questions, different ideas, or a project of your own in mind, leave a comment below. If you found this video useful, please like it and subscribe to the channel for future builds. Thank you for watching all the way through.